Hi cohort, tonight I'm going to try to produce two videos, one with the background on hypothesis testing and a second showing how to use that background to do homework problem number 13. I tried to do this earlier tonight but the video was too large, so I'm going to try to talk faster and put it in two smaller videos. So here are some slides with the background of hypothesis testing. Okay. So basically, in hypothesis testing, this is the big overview. You're going to make a statement about entire population, or in other words, entire group, a statement about all 8th graders, or in a statement about all high school students. You're going to gather some sample data, and you're going to use that sample data to test whether you believe the statement about the population is true. And then that's the overview of hypothesis testing. You start by writing two hypotheses. A null hypothesis, which always has an equal sign in it, and an alternative hypothesis, which always has a less than, a greater than, or a not equal sign in it. And depending on the sign in your alternative hypothesis, you're either looking at one of these three types of tests: two-tailed, left-tailed, or right-tailed. So basically, when you do a hypothesis test, there's 5 steps: assumptions, hypothesis, test statistic, p-value, and conclusion. So assumptions, the basic assumption was that your data was gathered randomly using randomization, and there could be some other assumptions based on the type of test you're running. The second step is to write your null and alternative hypothesis. The test statistic is the next step, and this is where I highly suggest that you let a calculator or some kind of technology do this for you. I have a calculator I can lend you. You can download a calculator from the internet, or you can even get statistical calculator apps for free for your phone. So, but I really highly recommend that you let step 3, the test statistic, and step 4, the p-value, be done using technology. So let's talk a little bit about the p-value and the test statistic. When you do hypothesis testing, you have some assumption about your population that the mean of your center or the mean of your population is somewhere in the center. And what you have instead is you have some data. Now your data might be a little bit to the right of the center. And so the question is your data so far different from where you think your center is that you're going to conclude that the center can't be here, that it has to be in some other location. And you do that based on this blue region, which is called your p-value. And I'm going to demonstrate this with homework problem 13. If you have a small p-value, you have strong evidence that your null hypothesis is not true. If you have a large p-value, then you don't have evidence that your null hypothesis is not true. And what's small and what's large? Usually 0.05 is the cutoff. So anything smaller than 0.05, you have strong evidence. Anything larger than 0.05, you don't. And then you come back and you write a conclusion that interprets what motivated you to do the test in the first place. This is how I help my students learn how to write their conclusions at first. If you reject your null hypothesis, then evidence suggests that your HA is true. If you don't reject your null hypothesis, and again, this is based on your p-value, then you don't have enough evidence that HA is true. But your conclusion is always about HA. And that's it. So I'm going to, in my next video, hopefully that was short enough to upload to YouTube. In my next video, I'm going to apply that to do homework problem 13.